let's have a look on magnetic effect of electric current. As we know, if a charge is at rest, then it produces electric field around it. Now, what are the possible cases that will happen to a charge? Either it will be at rest, either it will be moving at constant velocity, or either it will be accelerating. So, if a charge is moving with a constant velocity, then it produces magnetic field around it, and the moving charge is known as the current. So that is the names there, that magnetic effect of electric current. So let's have a look. If a charge is at rest, it produces electric field. Charge is in motion, constant V, magnetic field. Now, what are the various cases that magnetic field is produced? Either it will be produced by a permanent magnet, either it will be produced by a current carrying conductor, or either it will be produced by an electron revolving around the nucleus. So let's have a look on how a magnetic material behave when it is placed in a magnetic field. So let's have a magnet here. This is north pole, this is south pole, and these are the magnetic field lines going out and out. Now, magnetic field lines originate from this north pole and come to south pole outside the magnet. But inside the magnet, it goes from south to north pole and form a complete loop. That's why in case of magnet, monopole does not exist. Why? Because if you cut this magnet, again you will get, if you cut this magnet from here, again you will get two interfaces. This will become north and this will become south. That's why monopole does not exist in the magnetic field or magnetic field lines. Now, this is the magnet. Now, if we place some magnetic material here, let's say this is our material. Now, what will happen? Due to this magnetic field, now this material consists of charges. No, so due to this magnetic field lines, these charges get affected. Means this material get magnetized by this presence of this permanent magnet. So there are various terms which can be defined here. What are the terms? First one, magnetizing field. Magnetizing field. That is, what is magnetizing field? The field produced by this magnet is the magnetizing field, which are responsible for magnetizing this material. Second one is the magnetic induction. Magnetic induction. Now, what is magnetic induction? Magnetic induction means something is produced in a material due to the effect of surrounding. So something is produced here. What is produced? Magnetic dipole produced here due to presence of this magnetic field. Okay. Now, magnetic induction is what? The total magnetic field exists inside this material is equal to, or it is proportional to what? The external magnetic field, which is represented by H, plus what? The magnetization happen inside this material due to this external magnetic field, that is M. So you have seen this formula, mu naught H plus M. Okay, what is mu naught? Permeability of this space. What is M? Magnetic field intensity. What is magnetic field intensity? This is the magnetic field intensity. It is defined on the basis of the source, that up to what extent the source can produce the magnetic field. So that is represented by this H. And up to what extent the material get magnetized, that is measured in terms of this intensity of magnetization. So these are the case. Another term is the magnetic susceptibility. What is magnetic susceptibility? Magnetic susceptibility is simply the ratio of M by H. Now these are the basic things before we discussing the classification of material. Okay, so let's have a look on the classification of this material, magnetic material. Now, on the basis of the behavior of magnetic material in the external magnetic field, the material can be classified into three categories. Let's discuss first one, which is diamagnetic material. Diamagnetic Now, what is diamagnetic material? Such type of materials are, when placed in a magnetic field, this material gets feebly magnetized or weakly magnetized by this external magnetic field and tends to move from the stronger to weaker part of the field. In simple word, you can say this material hates the magnetic field. It does not like magnetic field. So, why it has happened? So, let's have a look on the origin. Now, in this type of material, what happened? The electrons occurred in pair. So, one is moving in anti-clockwise direction and another is moving in clockwise direction. So, let's have a look. Now, let's say this electron is moving anti-clockwise with velocity v. Okay, this is the direction. And this electron is moving clockwise with velocity v. Now, electron is moving in anti-clockwise, so current will be moving in downward direction, that is clockwise. Now, by using right hand rule, what you will suggest that current is moving in this direction, so the magnetic moment will be in this direction. And electron is moving clockwise, so the current will be moving in anti-clockwise and the magnetic moment is in upward direction. Okay, now this is the case when no magnetic field is applied. Now let's apply some external magnetic field here. This is B external. Now what will happen? Now this magnetic field will increase the velocity which is aligned in the direction of this magnetic field. So which electron is moving in the direction of external magnetic field? This one. So its velocity get increases, let's say by delta V. Due to increase in its velocity, its magnetic moment also increases. In vice versa case, the electron which is moving against this magnetic field, its velocity get decreases, due to which its magnetic moment also get decreases. Now, due to presence of this magnetic field, magnetic moment changes. Up to what extent or what is the quantity that will change in the magnetic moment? That is minus delta M and plus delta M. That is, change will be 2 delta M. But this change preferred in which direction? That is opposite to the external magnetic field. That's why the diamagnetic material does not like the magnetic field. It tends to move from the stronger to the weaker part of the field. Now, next one is paramagnetic material. Paramagnetic material. Now, such type of material, it also gets weakly magnetized, but it loves magnetic field. It tends to move from weaker to stronger part of the field. Now, why it is happened so? Because such type of material having unpaired electron in their outermost shell. Now, what will that unpaired electron do? See, we know magnetic moment is produced by basically by three cases. Either by permanent magnet, either by a current carrying conductor, or either by an electron revolving around the nucleus, a single electron. Now, such type of material contain a single electron. That's why it will have its own magnetic moment even when no magnetic field is present. But when there is no any magnetic field is present, let's say this is a paramagnetic specimen, and this is an atom. Now, when no magnetic field is present here, what will happen? That every atom has its own magnetic moment. This arrow represents the direction of this magnetic moment. Now, when no, let's let no be external. When no magnetic field applied here, what will happen? Each atom has its own magnetic moment, but when no magnetic field apply here, they are randomly arranged due to which their net magnetic moment is zero. But what happens when you will apply external magnetic field? This will align in a particular direction. This will align in particular direction. Okay, this, let's say this direction of B external. This will align in the direction of magnetic field, due to which they have a net magnetic moment in the direction of magnetic field. And Curie law apply here, that the magnetic susceptibility of this material is directly proportional to 1 by T. That is this way. That is, on increasing the temperature, this magnetic susceptibility decreases. Why? Because on increasing the temperature, this dipole get randomly aligned, due to which the magnetic susceptibility decreases. And last one is ferromagnetic material. Now, what is ferromagnetic material? Such type of material are highly magnetized in the direction of magnetic field, but such type of material had its own magnetic moment, due to which their magnetic moment interact with other magnetic moments of atom and form a group which is known as domain. And this domain consists of 10 to the power 11 atoms. But what will happen when no magnetic field is applied? Let's say this is our domain. This is our domain. Now this is our domain. This is our domain. This one. This is about 1 mm of size and consists of 10 to the power 11 atoms. But when no magnetic field is applied, this domain, align randomly in every possible direction, due to which their net magnetic moment is zero. But magnetic field is applied when this will align in the direction of magnetic field. This will align in the direction of magnetic field, due to which this material possesses a net magnetic moment in the direction of magnetic field. So these are the classification of magnetic material on the basis of their behavior in the external magnetic field. Thank you.